When we look up at the night sky, we see thousands of tiny points of light, distant stars scattered across the vast universe. But hidden among these celestial objects are true giants, hypergiants, some of the most powerful, luminous, and awe-inspiring stars in existence. Hypergiants are so massive that they dwarf our sun, burning through their fuel at an extraordinary rate and living fast, explosive lives. These colossal stars challenge our understanding of astrophysics, and today we embark on an incredible journey to explore their mysteries. What makes hypergiants different from other stars? How do they form? And what happens when these cosmic titans reach the end of their lives? Let's begin our voyage into the world of hypergiants, some of the largest and most extreme objects in the universe. Stars come in many sizes, from tiny red dwarfs to sun-like stars, and then there are the supergiants. But beyond even them, at the very top of the stellar hierarchy, we find the Hypergiants. Hypergiants are a special class of stars with extreme luminosity and mass. They are typically 30 to 300 times the mass of our sun, and they shine millions of times brighter. These stars are classified based on their spectral types, ranging from yellow hypergiants like Rho Cassiopeiae to blue hypergiants such as Rigel, and red hypergiants like VY Canis Majoris. What sets hypergiants apart is their instability. Unlike smaller stars, they constantly shed vast amounts of material into space, forming spectacular clouds of gas and dust around them. But how do these giants form in the first place? Hypergiants are born in regions of space known as stellar nurseries, vast clouds of gas and dust, where gravity pulls material together to form new stars. However, to create a hypergiant, an immense amount of mass must come together in a short time, forming a massive protostar. As nuclear fusion ignites in the core, the star enters the main sequence, but due to its immense size, it burns through its hydrogen at a breakneck pace. Only the most massive molecular clouds in the universe can give birth to hypergiants, making them incredibly rare compared to smaller stars like our sun. Some hypergiants are among the most luminous objects in the universe. Take for instance Eta Carinae, one of the most famous hypergiants. Located 7,500 light-years from Earth, this stellar behemoth shines more than 5 million times brighter than the sun, and is constantly shedding mass in violent outbursts. Or consider UY Scuti, one of the largest known stars in terms of sheer volume. If placed at the center of our solar system, its outer layers would extend beyond Jupiter's orbit. These stars are not only bright, but also turbulent. Their immense energy causes extreme solar winds, and their surfaces are constantly in a state of chaotic motion. Unlike smaller stars, which can live for billions of years, hypergiants have incredibly short lifespans, typically just a few million years. As they burn through their nuclear fuel at an accelerated rate, they experience dramatic changes. Some expand and contract, transitioning between different spectral types, while others eject massive amounts of gas, forming spectacular nebulae around them. This extreme instability means that hypergiants are constantly teetering on the edge of destruction. Every star must eventually meet its end, but for hypergiants, this finale is truly spectacular. When a hypergiant exhausts its nuclear fuel, its core collapses under immense gravitational pressure, triggering one of the most powerful explosions in the universe, a supernova. This explosion releases more energy in a few seconds than our sun will produce in its entire lifetime. Some hypergiants go out with an even more extreme fate. They collapse directly into a black hole, forming some of the most enigmatic objects in the universe. Studying hypergiants helps astronomers understand the most extreme conditions in space. These stars reveal insights into stellar evolution, galactic dynamics, and even the formation of black holes. Thanks to powerful telescopes like Hubble, James Webb Space Telescope, JWST, and ground-based observatories, scientists are uncovering new secrets about these massive stars, but there is still so much to learn. Could even larger stars exist in the distant universe? Are there hypergiants that defy known physics? The cosmos continues to surprise us. Hypergiants are more than just enormous stars. They are the architects of galaxies, the creators of cosmic elements, and the catalysts of spectacular celestial events. While their lives may be short, their influence echoes across the universe. The elements forged in their fiery cores become the building blocks of planets, moons, and even life itself. As we continue to explore the universe, one thing is clear: the story of hypergiants is far from over. With new discoveries on the horizon, these cosmic titans will continue to captivate and inspire us. If you enjoyed this journey through the universe's most massive stars, don't forget to leave a like. It really helps support the channel. Have thoughts, questions, or your own favorite hypergiant star? Drop a comment below, we'd love to hear from you. And if you love space, astronomy, and mind-blowing cosmic discoveries, make sure to subscribe and turn on notifications so you never miss an episode. Tune in next time for cosmic adventures.